All right, this is a video on how to complete the square. So let's talk about maybe in the context of, because that's where it's more going to be useful for you, putting a quadratic in completed square form. Because you can solve a quadratic by completing the square, but I feel like most people either factor or use the quadratic formula. But if I'm asking you to put a quadratic in completed square form, you have no choice. So we're going to do a basic one and then one a little bit trickier. So the basic is when the coefficient of the squared term is 1. So let's do x squared minus 6x. Let's do plus 12. Okay. So if I'm asking you to put this in vertex form or completed square form, first thing you're going to do is I'm just going to change f of x to be y, just so I don't have to write f of x every time. So y, subtract the 12, and I've got x squared minus 6x. And remember, the goal is to get this side to be a perfect square. And to do that, I'm going to take half of that linear coefficient, what's in front of the x, and that's giving me -3, and then I'm going to square that. So -3 squared is 9. That's what I'm going to add here. And because I don't want to change the equation, I'm just kind of manipulating the look of it. Anything I do to one side, I've got to do to the other. So I've changed the right side by +9, so I've got to change the left side by +9. So I've got y minus 3 equals... Now, x squared minus 6x plus 9 is this perfect square now, x minus 3 squared. And one thing to note is what goes here is always what you get after you half that linear coefficient. That's what's going to end up going in here if it's not obvious how it factors. Okay, almost done. So now just solve for y. So in completed square form, this would be x minus 3 squared plus 3. And the vertex here would be 3, 3. Okay, so let's talk now. And the reason this was simple again was because in front of x squared was just 1. And in order to complete the square, you need that to be 1. So let's do a different type of problem. Let's do something maybe a little trickier. But maybe use similar numbers. What if I have, I'll call it g of x, equals -1/3 x squared minus 6x, let's see, I guess I'll do plus 12 again. So kind of similar, but the coefficient isn't 1 in front of the x squared. Okay, first let's start off the same way. I'm going to bring over the constant. So I have y minus 12 equals, now I just said in order to put it in completed square form, where I have x minus or x plus something squared, I've got to factor out this leading coefficient. So I've got to factor out -1/3. And when I do that, remember factoring out is the same as dividing. So -6 divided by -1/3 is going to be positive 18. I still have that x. And just to double check, you want to make sure that if you FOILed this out, nothing has changed. You should still get -1/3 x squared minus 6x, which I do. So that's a good double check. Okay, now I'm ready to complete the square. I'm going to take half of the linear coefficient, so half of 18, which is 9, and then I'm going to square that, so 81. So I'm going to add 81. But remember, be careful. How I've changed this side isn't by just adding 81. I got to look that if I were to FOIL this out, I've actually changed it by -1/3 times 81. And that just happens to be -27. So if I FOILed this out, I'd get -1/3 x squared minus 6x minus 27. So I've got to subtract 27 from the other side. Okay, we get y minus 39 equals -1/3 x plus 9 squared. That's this factored. And the last thing is just add 39. So -1/3 x plus 9 squared plus 39. And my vertex in this case would be -9, 39.